Hello everyone, my name is Piotr Bała and I am professor of the computer science at the University of Warsaw. Today I would like to share with you our experience with a master degree course in computational engineering we are running at the University of Warsaw. So let me first tell a few words about the university. The University of Warsaw is the largest university in Poland with 200 years of history. It employs about 3,000 academic staff and enrolls about 50,000 students. We have 18 faculties doing research in many disciplines. There are over 100 teaching programs at the university, both on the undergraduate and graduate level. The program in computational engineering is run at the Interdisciplinary Center for Mathematical and Computational Modeling, ICM. ICM was founded in 1993 as a research center in computational sciences. It is also a high-performance computing center, providing resources to the researchers from the University of Warsaw, as well as to the researchers all over the country. The resources we have is Cray XC40 and number of PC clusters of different architectures. The motivation for running a master degree course in computational engineering was quite obvious. There is a number of the students in computer science in Poland and also worldwide, but still the number of graduates is not enough to fulfill the demand of the market. Another issue is a background of those graduates. They have quite limited skills in the running simulations or running large-scale infrastructures or dealing with large data. So the education does not keep with the demand of the market. And we decided at ICM to address this problem and create a dedicated program to train students in these areas. Master degree program in computational engineering is a 3-semester postgraduate program. So this is second level study according to the Bologna process, or we can call this as a graduate program. The students are granted with the master degree in computer science. Program is practical, so it means that more than 50% of the classes are in the form of the practical lectures. The course has been designed for the people with the domain-specific knowledge. So for the students who already finished first level studies and received engineer or master degree. Bachelor degree is not enough to enroll in our studies. Majority of the applicants received their degree out of the University of Warsaw. So this is also important for our university to open to the students from other backgrounds. Usually they come from the technical university in Warsaw or other cities. The program is relatively small, so we enroll 15 students each semester. So enrollment is 2 times a year. Acceptance rate is about 60%. So we try to pick up students carefully, looking on their background and looking on their competence and ability to finish our program. Study program is entirely defined based on the learning outcomes. So it's very important from the formal point of view, at least in Poland. The master degree program is consisting of obligatory courses and courses who are picked up by the students from a larger offer. In the first semester, students have like 3 courses to do obligatory. One of them is mathematics, another is introduction to high performance computing, and the third course is parallel programming. Obligatory courses in the second semester are simulations in natural sciences and simulations in social sciences. And their aim is to provide students with the example usage of the large-scale infrastructure and simulations to solve problems in the different areas. Students have obligatory internship, which can be done at ICM as HPC Center, or can be done in other HPC Center, or it can be done in companies, in industry, with profile dealing with large infrastructure or dealing with simulations. The other courses which are picked up by the students are like visualization, simulations in various areas, for example, physics, medicine, transportation. We offer also courses in artificial intelligence and deep learning. Students have to take 3 such courses, each course in 1 semester of studies. In terms of the topics we are teaching students, they are very much aligned with other HPC related programs. So we provide introduction to high performance computing systems. We provide information on the computer architectures, processor architectures, networks, data storage systems. Students learn about queuing systems and how to use them in practice. We teach them code compilation, compilers, profiling technologies, code optimizations, including scalar and vector optimization. Students are learning how to install software and how to install numerical libraries and how to use them in practical applications. There is introduction to grid and cloud technologies, virtualization, and related things. We teach them how to use computing portals. As I mentioned, parallel programming is very important, and we teach MPI, OpenMP, GPU, as well as Pegas programming model. We also provide lectures on Hadoop and Spark. We try to be as novel as possible, so there are also lectures on quantum computing, and the whole program is divided into more or less standard knowledge in the HPC area, as well as novel solutions which are available in this field. Few words about students. They are quite well motivated and they are interested in participating in our program. They are quite well prepared, so their background knowledge, domain-specific knowledge is quite good. Some of them have also some knowledge in computer science, in programming. However, this knowledge is extended by the program we are in with them. Profile of the students is in general similar to the profile of the users of the HPC Center. So the background of the students is in physics, chemistry, biology a little bit, mechanical engineering and other engineering programs. Our program is very much interdisciplinary because the background of the students is the interdisciplinary, and the program itself is interdisciplinary. And this makes a very interesting outcome of the program. And we see that it's a very strong benefit compared to the other programs running Poland. There are also some students with the background which is not directly sciences. So there are students who have degree in linguistics or in medicine, but they also fit very well to our program. Students are using HPC resources at ICM on the same basis as HPC users. The resource allocation is about 500,000 CPU hours per year. We are not using this allocation fully, but quite significant part of it. As I mentioned, some of the students are also working during the summer at ICM in terms of the internship. Our The performance of our students is presented in the graph. So you can see the percentage of the students enrolled for the second semester. Up to now, we had like 8 programs started. So you can see the performance of each group of the students, and you can see that the performance increases, and there are two reasons of that. One is that we are picking better prepared students for our program, and also we are trying to adjust the program itself to better prepare students for the second semester and help them to pass the first semester of the studies. In red, you can see the number of students or percentage of the students who finish with the diploma, and this is about 20–30%, and it is definitely low, but the number is very similar to the other computer science programs in Poland. The demand of the market is really high, so the student decides to go to the industry before finishing studies or before defending their thesis. And we see that after like 2 semesters or 3 semesters of the study, their value of the market is really high. Some other students' achievements, our students are taking part in the hackathons run at the ICMs. The hackathon itself is to solve real-life problems using large-scale infrastructure. The problems are so huge that they do not fit to the typical laptop or computer, so you have to use HPC resources. Data is usually large. And our teams are taking the top places in the ranking in such hackathon, and their achievements are significantly higher than the achievements of the students from other computer science programs. So it means that the students are quite well prepared for doing this job. And a second important achievement is that quite large number of students or our graduates is already employed at the ICM, so at the HPC Center. The employment is based on the open competition with the other applicants coming from other studies, usually computer science. And our students are well prepared and they have good predispositions to work at the center, both in the terms of running large-scale infrastructure or doing software work or doing simulations. So it means that our program quite well prepares students for this kind of the job as we prepare this. So to conclude my talk, I presented you very briefly a program which is very new at University of Warsaw. The program is dedicated to train students in HPC area. The program is dedicated to the non-computer science specialist, and this is different approach than from the most of other programs dealing with HPC training. Students have a practical profile, and they equip students with the skills necessary to be familiar with large IT infrastructure and to run simulations. And the students' achievements, as I presented in this talk, are quite high, and they show that the program is really working and we achieve purposes we assume that the starting this program. Thank you very much for the listening.